Okay, this is just a video about resolving, or what we say, resolution of a vector into components. And what that means is if you have a TV that's high resolution, that means the image that it's projecting has been broken up into lots and lots and lots of different pieces. So it's a high resolution. So what resolution just means is to breaking up into smaller chunks. And so what we're going to do is look at how we break up a vector into smaller pieces. So just to give you a quick overview, you have a vector like that, we break it up into two pieces. We break it up into a horizontal component and a vertical component. Okay, so that's the original vector. We're going to break it up into this and this. And basically it makes vectors easy to talk about and to add together and that sort of thing. Very, very important. But before we get into that, we're going to start with unit vectors. And you can probably guess what a unit vector is. A unit vector has magnitude of 1. So it has a length of 1 unit. And so let's have a look at that. Let's just have a look at what a unit vector might be. So I'm just going to do it this way because I always do it the same way, like this. Here's a vector C. And let's say that C has length 7. Okay, magnitude of 7. How could we change this vector C into a unit vector with the same direction? Well, if it needs to have a magnitude of 1, what we need to do is to probably divide this by 7. So it's got a magnitude of 7, we need to divide it by 7 so that it has a magnitude of 1. So the unit vector, what it looks like is this. C with the tilde, we put a little hat on it. The hat represents a unit vector. Okay, so C is equal to, what do we do to make the unit vector? We take the vector C and we divide it by 7. And that gives us a unit vector. It has a length of 1 if we divide it by 7. How about if we had another vector out here, D, that has a length of 21? How do we do it? Well, the unit vector, the little hat and the tilde, will be equal to the D vector, but let's divide it by 21. And that gives us our unit vector of length 1. Still the same direction, but length 1. And so in general, if you've got a vector A and you want to find the unit vector of that, it'll be equal to the vector of A. And what do we divide it by? Well, what do we do each of them? We're just dividing it by the magnitude of the vector. So you divide by the magnitude of A. And that is the formula for figuring out the unit vector of any vector. And so that's nice and simple. Okay, so the next part we want to talk about is some special unit vectors. Okay, so let's just have a look at this. I'll do my best at drawing three-dimensional. It's always a bit weird. X, Y, and Z. And just change the colours. Right. So we've got an X, Y, and Z plane, 3 dimensions, and if we come out one unit in each direction, 1, 1, 1, and we create a vector of length 1, there, there, and there, then we give these special names. The unit vector that goes along the x-axis, we give the name of I. It's a vector of length 1, it's a unit vector. The vector that goes up along the y-axis in a vertical direction, we give the name J. And similarly, you can probably guess, a unit vector in the direction of the z-axis we call K. And so this is how this works. And basically we can, well, before I get into that, let's have a look at it. So, how do we write as a column vector, how do we write I? Well, how far in the x direction does it go? It goes 1 unit. How far does it go in the y direction? 0 units. How far does it go in the z direction? 0 units. So I looks like that. What does J look like? Well, J looks like, how far does it go in the x direction? Nothing. How far does it go in the y direction? 1 unit. And how far does it go in the z direction? None. Awesome. And K, what does K look like? You can probably guess it's 0, 0, 1. And these are three linearly independent, they're independent vectors that work together so that you can name any vector anywhere. And so if you have some vector, like say we have this vector here, let's just say 2, -3, and 1, something like that. What we can do is just rewrite this as 2 lots of 1, 0, 0. So that's that 2 up there, minus 3 lots of 3's in the second one, the j column vector, and then 1 lot plus 1 lot of the k vector, 0, 0, 1. So if you know your matrices, you'll know that this is equal to that. We've just broken it up. And remember that there, that's I, that's j, and that's k. So that can just be written as 2i minus 3j plus k. So these two are equivalent. That's two different ways of writing it. We'll find that when you're sort of using algebra with vectors and that sort of thing, this is much easier to think about in an algebra sense. When you think of it, vectors in terms of matrices, it's easier to write like that. But they are the same thing. This is a very easy way to think about vectors. Oh yeah, this vector goes 2 in the x direction, -3 in the y direction, and 1 in the z direction. So that's a bit about our special unit vectors I, j, and k. Let's just look at quickly equivalence. When are two, I'm a bit out of breath, talking too much. And so we'll just look at equivalence. In fact, I might just end the video there, come back and do equivalence in a different video.